Assalamualaikum warahmatullahi wabarakatuh. In this video, you are going to see how to find the area bounded by curve or curves, and there are two parts in this section 6.3. The first part here is dealing with the area of region that lies under the graph of a function. So there's just one function. And the second part of this section 6.3 here will be dealing with the area or region that lies between the graphs of two functions. Okay, so in this video, what you'll be looking at is the area of region that lies under the graph of a function. So the function is given as fx. So basically there are four different cases that you will see in this part. So the first case is when you have the curve that is entirely above the x-axis. So this is an example of having the curve which is entirely above the x-axis. So in order to find the area, it is a very straightforward process of finding the integral of this function. So the function here is fx, so you just integrate it as usual from the limit a to b. Next, you have the second case where the curve is entirely below the x-axis. So therefore, what you need to do is you need to find the absolute value of this integral. And you have seen this before. I've explained this idea before this. When you have the curve which is below the x-axis, then the area obtained here is going to be a negative value unless you unless you use the absolute value here and turn it into a positive result. Okay. Alright, next, the third case is where you have some parts of the curve above the x-axis and another part is below the x-axis. For example, this is below the x-axis and this is above the x-axis. Therefore, the area should be evaluated accordingly. For example, this area is going to be positive and this area is going to be negative. So you have to turn this area into a positive area and then you will find the total area of this. Okay. Next, sometimes you might be asked to find the area where the area is in this manner. So this is the area here where you can see that it is easier to integrate this function. So integrate this function with respect to y. So this is the y-axis. So it's easier to integrate the given function, the curve, with respect to y instead of dx. Okay, so these three examples are examples that are related to integrating the given curve with respect to x. So this is with respect to x. But the fourth case is here, you will see that in some circumstances it is easier to integrate the function with respect to y, and therefore you need to be able to re-express the function from y equals to fx to x equals to fy and integrate that with respect to y. Okay, I think that's all for now. Thank you very much for watching, and I will see you in the next video with more examples related to these four cases here.